The International Space Station is always looking at cost-effective ways of performing research in space, and a new payload that arrived at the station on SpaceX-4 is proving that. We're going to head out next to the Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama, where Lori Meggs is on hand to tell us more about that. Lori?
Rapidscat is an instrument that will measure ocean wind speed and direction and could help with weather forecasting and improve that and hurricane monitoring. It was installed on the ISS just this week and will undergo checkouts later today. Prior to its launch on SpaceX-4, I caught up with the project systems engineer from the Jet Propulsion Laboratory to learn more.
Rapidscat is a very unique mission. We are taking engineering model and flight spare parts that were from a mission that launched in 1999. We took them out of storage, we put a commercial interface onto those parts and tested it, and we are able to then provide big mission science at a very small fraction of what it usually costs to do that type of mission. We had a small team, a very short schedule, a very small amount of money, and we're getting really big science out of this. And we're going to be the first payload put on the space station that's actually assembled in 2 pieces. And once we're installed, we'll start to rotate our antenna. So we're the first rotating radar on the outside of the space station.
Right, so when you say installed, you're installing outside the station.
Yes, we're installed outside on the Columbus module. It's called the SDX location, and it's a site that faces basically out to space. And since we're trying to measure ocean wind speed and direction, we need to look down. And so one of the first things we had to figure out is how to see the oceans from that spot. And so we basically built a 2-part payload. And so the first part installs on the Columbus module, and that gives us a base to install our second part of the payload to look downward towards, we call it nadir.
Why do we need to use the platform of the ISS to study ocean winds?
Well, there are a few reasons that we use the space station. One is practicality. We were given a free launch, a free ride to space. We were given a platform that gave us power, that gave us a stable place from which we can make the measurements, and we have that location for 2 years. And so it really is saving us quite a bit of money, and it's allowing us to actually do this science. But there are also great science benefits to using the space station orbit. Most of the scatterometers that have been put into orbit so far have been in what's called a sun-synchronous orbit, and that means that they see the same spot on Earth at the same time each time they visit it. So they'll be measuring ocean vector winds, but only at one particular local time of day. On the space station orbit, we actually sample many different times of day. And so over a period of about 2 months, we'll fully sample all of the times of day. So we'll be able to say something not just about ocean winds, but how ocean winds vary over the course of a day. And that's really exciting. And one more thing we get to do from a science standpoint is, because we're flying at a lower altitude and at all of these different times of day, we will underfly the other scatterometers that are in orbit that are each measuring at their own single time of day, so that we can for the first time better compare them to each other, because we'll measure the same place at the same time as each of the other scatterometers in space, which will let us see if they get different measurements. Is it because they're looking at different times of day, or is it because the instruments are different? And so by being able to, we call it cross-calibrating those instruments, we're adding value to the entire constellation of scatterometers in space.
What will we use this data for?
Rapidscat data is going to be used for quite a few things. We'll be used to help improve weather forecasting. We'll also be used to help monitor and track severe storms like hurricanes. And so getting the space station's orbit, which gives us great coverage over the tropics. In fact, we can cover everything between plus and minus 57 degrees latitude. We'll be able to get coverage of that region about every 2 days, which will give us a lot of extra data points, which will help us improve the weather forecast. It'll help us improve severe storm tracking, and it's also going to help us understand about the ocean-atmosphere interface. So there's a great wealth of science and applications to come from Rapidscat.
And taking a live look into the Payload Operations Integration Center, you see a little pink in there. The signs are lit up pink. It's Pink It Up MSFC Day, and they're pinking it up in the POIC. We are encouraging everyone to wear pink and increase awareness of the importance of early breast cancer detection. And we're taking selfies and taking photographs and posting them on our Marshall Twitter site, so you might want to check that out. Remember, awareness plus early detection equals saved lives. And we thank the folks in there for showing their support today and the hard work that they're doing supporting all the astronauts on the ISS.